domain range example too. Yeah. Okay, so my other two classes got through that. So, okay, guys, this is a good review though. Okay, which axis is which? We've got the x-axis and y-axis. Okay, we've got another parabola. This one is upside down though. Okay, so that whole x squared tells me it's a parabola. What tells me it's upside down parabola? The fact that it's a negative x squared term. Okay, domain. Which ways are we looking at for domain? We want to talk about how far out, okay? How far left and right? So on the x-axis. So with that in mind, oh, and it's a parabola, so what do we assume? Okay, it's continuing going on there. How far are we going left? Infinite, yes, because as it's going down, it's getting infinitely wider on the left. What about on the right? As this parabola is going down, it's getting infinitely wider on the right. What's that say my domain is? Infinite. Okay. Could we say negative infinity to positive infinity? Yeah. Okay, what else could we say? All real numbers. Or x, such that x is a real number. It won't always be the same, but my domain on these three has been the same every time, hasn't it? Okay, so any of those options are fine with me. You could say all real numbers. You could use the fancy set notation that says x, such that x is a real number. Or we could use interval notation that says, okay, it's going infinitely left, so negative infinity, to infinitely right, which is positive infinity. Okay. Take a moment and start thinking about range now. Range are which kind of values? Range are the y values. Good. So now we're talking up and down. Okay. So with that in mind, how low and how high does this go? How low does this graph go? It's going infinitely low, isn't it? Okay. So if we think about that interval notation, it goes down to negative infinity. Infinities in interval notation always use parentheses. Good. Okay. How high is this going? How high does this parabola go? Yeah. So if you look at the way it's counting, I know what you guys mean, but if you look at the way it's counting every two lines, so technically this is 4.5. I think if you look at this ordered pair, I decide that this ordered pair is 1.5, comma 4.5. And which value do we need? Since we're talking range and up or down, we need the y value. So this is going up to 4.5. Parenthesis or bracket. Does the graph touch 4.5? Yeah, we touch a point that's on the 4.5 line. So that means if you recall from yesterday, we're going to use a bracket. I think freshmen and sophomores are out of their meeting now. Okay. How do we write this in set notation? So how do we write this with less than, greater than? The number we used was 4.5. So in relation to 4.5, where is this graph? Okay. It's below, so it's less than. It touches 4.5, so we want to say less than or equal to. Good. So if I use the fancy stuff, the fancy little brace, y such that, and this is the part that I care about, y less than or equal to 4.5. So as I said yesterday, I'm showing this so in case you see it, you can be comfortable with it, but as long as you can come up with the y less than or equal to 4.5, I'm good. Hi.
Thank you.
Okay. You got an idea of domain and range, yes? Because you're going to see domain and range. I went through and got the homework set up last night, and sometimes they ask for interval notation. Sometimes they ask for inequalities. They are not consistent. It bounces back and forth. So, with that in mind, you want to be comfortable with both. Okay? When it comes to my test or a quiz at the end of the chapter, middle of the chapter, I'm not going to specify. I'm just going to say, give me the domain. So you can write whichever one you are more comfortable with. But Savas is going to force you to practice both. Okay? Okay. Bottom of this page. We're going to talk about something called x-intercepts and y-intercepts. Okay? As we talk about x-intercepts and y-intercepts, remember what an x-intercept and y-intercept is?
I don't even know. Is it where like they cross the x and y?
Yeah. An x-intercept is where the graph crosses the x-axis. A y-intercept is where the graph crosses the y-axis. Okay, so x-intercept, it's the x-coordinate of a point where the graph intersects the x-axis. Y-coordinate is the y-coordinate of a point where the graph intersects the y-axis. Okay, so intercepts. Now, a little bit of vocabulary just in moving forward. We won't really do anything with it in this homework, but x-intercepts are also known as zeros. So when we start talking about the zeros of an equation or a function, those are also the same thing as x-intercepts. So, okay, guys. If an x-intercept or a y-intercept is where it crosses the axis, what number is always involved in a point on an axis? Whether it be x-axis or y-axis, there's always going to be a zero involved. Okay, so when I ask you to find the x and y intercepts, my hint is you put 0 in. Now, if we want to find what x is, you don't want to put 0 in for x, you want to put 0 in for y. Okay, if we want to find what y is, you don't put 0 in for y, you put 0 in for x. Okay, so with this in mind, we've got two examples here. Find x and y intercepts. Now, could you graph this and look at where the x and y intercepts are? We could, but we don't have really good graphing. You know, we haven't talked about how to graph these yet. So, with that in mind, let's find the x-intercept. So in order to find the x-intercept, what do I want to put 0 in for? The y. So what I'm going to say right here is let y equal 0. That's my first step. So when I say let y equal 0, that means I'm going to put 0 in place of this y. So kind of a basic equation to solve. So now I'm going to write this equation as 0 equals absolute value of x minus 3. Okay. How do I solve for x? Go back to the basics. Oh, yes. And there'll be a video online, or you can get a picture of the notes to get caught up, okay?
Add 3 to 0.
Okay. Yeah, if we want to get x by itself, there's currently a minus 3 hanging out with it. The opposite of subtracting 3 is to add 3. This sounds familiar, doesn't it? So if you add 3, you add 3. We have the idea that 0 plus 3, which 0 plus 3 is 3, equals the absolute value of x. Now, I don't know how much you remember about absolute value and solving absolute value, but what is apparent? One thing is that x can equal what? X can equal, if this is absolute value of x is 3, we could put 3 in there. What else could you put in for x and get 3 out? Did we talk about absolute value in this class the other day? I don't remember which class some classes I did, some classes I didn't. What do you think? Not one. Okay, absolute value. It's the distance from 0 on a number line. So if here's 0 on my number line, 3 is over here, yes?
Yeah.
It's 3 away. What's over here that's 3 away? Yeah, -3. So we actually have two answers here. When you see absolute value of x equals a number, it can be the positive or the negative of that number. So I'm going to say I have two answers here. X could be 3, x could be -3. And it's just, if you remember absolute value, the shortcut we always talk about, when you put a number into absolute value bars, what do the bars do to the number? It makes it positive. So if I put 3 in here, it makes it positive. If I put -3 in here, it makes it positive. So what I know at this point is that my x-intercepts, there's two of them. My x-intercepts are 3 and -3. Now, will you always have two x-intercepts? Not necessarily, but you can. Okay? That just means my graph crosses the x-axis in two spots. Now, those are x-intercepts. What else do we need to find? Y-intercepts. So, we're going to find y-intercepts. Y-intercepts are on the y-axis. What do we need to make 0? X, the opposite variable. So this time, I'm going to say let x equal 0. So rewrite your equation by putting 0 in for x. So y equals the absolute value of 0 minus 3. What's the absolute value of 0?
0.
0. What's 0 minus 3?
0. Oh, wait.
-3.
Okay.
Okay. That one's a little easier to solve. Did we solve it? Yeah. What do we know now? My y-intercept is -3. Okay, so I know this graph crosses the x-axis at -3 and +3, and it crosses the y-axis at -3. Got the idea of what we're doing? Anytime. We do intercepts a lot in math. Okay, that's something that's going to keep coming back. So let's try our second equation. Let's look at g of x. How do we find the x-intercepts? X-intercepts, you put 0 in for y. So now, oh,
There is no one.
there is no y. Yes, there is. Where is y?
G.
G of x, yes? G of x is a fancy way of, is another way to say f of x. You often see f, right? F of x, G of x, any of those, that is the same thing as saying y. Okay, that's just another way to express it. So that equation is y equals 4 minus x squared. Are you good now? Can we put 0 in for y? Sure can. 0 equals 4 minus x squared. Okay. How would you like to start solving this for x?
4 from 0.
Okay. Subtract 4 over, or, and I'm good with that, what's the other option?
Subtract 0 from 4.
No. Maybe we should just subtract 4. We could subtract the 4 over here, and then we're going to have -4 equals -x squared. Or how can I make it so x squared isn't negative anymore? How can I move the x squared over here?
Add x squared.
Yeah, could we add the x squared over? And my brain is, here's the deal. Do we like to work with negatives? No. So my thought is let's just get rid of the negative while we can. So that's where I'm going to say is since there's a minus x squared and we're just trying to get these on opposite sides, which you guys are doing, I'm going to suggest we add x squared. If we add x squared on one side, we add x squared on the other side. So if you add x squared to 0, that's just x squared. The 4 is still over here, and the x squareds cancel. Okay. X squared equals 4. How do I solve for x? Do you remember, Brian? Hayden? Whoever you are? Baldwin? Sorry.
You take the square root of
Yes. Yes. Okay. We take the square root. Okay. If you have x squared and you're trying to get it to become x, you take the square root. If we take the square root of one side, we take the square root of the other side. Okay. So with that in mind, the square root of x squared becomes x. What's the square root of 4? 2. And what else? Negative 2. So I'm actually going to write this as plus or minus 2. So when you take square roots, you want to think about the positive option and the negative option. So plus or minus 2. So that means it says x equals, so these are my x-intercepts. My x-intercepts are 2 and negative 2. Okay. And we still need to talk about y-intercepts. How do I find y-intercepts? If I want to find y, I need to get rid of x. So we're going to let x equal 0. If I'm going to let x equal 0, then I'm going to have y equals 4 minus 0 squared. 0 squared is 0. 4 minus 0 is 4. So we just found that our y-intercept is 4. Okay. Now, this is how we find x and y-intercepts if we're given equations. How do you find x and y-intercepts if you're looking at a graph? You just look for where the graph crosses the x or y axis, right? Okay. You might be asked to write these as ordered pairs. Could we write these as ordered pairs if we needed to? The y-intercept is 4. What was the x value? 0. So this would be the ordered pair 0, 4 if you had to. I can't remember what Savas asked us for. X-intercepts, the x values are 2 and negative 2. What was the y value? It was 0, right? So we could write this. Try that again. We could write this as 2, 0 and negative 2, 0. Okay. So those are intercepts. I will tell you, Savas, you want to look at how they ask you to put the answer in. As you go through this homework, sometimes they'll say use inequalities. Sometimes they'll say use interval notation, so on and so forth. Okay, questions there? Okay, let's keep going. Okay, you do?
Yeah.
Okay.
Yeah.
Just checking. Okay. And Hayden, I'm sorry. Siblings, you guys are doomed. If I've had a sibling before, I'll get it eventually, but I've got to figure it out. So, okay. Next page. We've got 2 more big topics to talk about. This next one is positive and negative intervals. So again, Easiest way to do this is looking at the graph, which is what we're going to do. Okay. Positive intervals happen when the graph is positive. Now, when is the graph positive? Well, the graph is positive when it is up, when it's on top. So when we talk about a positive interval, we're looking at, so it says when the y value is positive. That is saying when the graph is above the x-axis, okay? Because the top half of the y-axis is where your y's are positive, yes? So that's what we're saying there. That means negative intervals happen when? When the graph is below. So if it's a negative interval, it's when my y's are negative. So my y's are on the bottom part of the y-axis, or when the graph is below the x-axis. Okay? So this is another key we're going to be looking at, is when is a graph positive or negative. So the directions read, for what interval is each function positive and is each function negative? Okay, so with this in mind, first of all, where is the x-axis? At 0. You got it spotted here? I'm just kind of drawing it in for you, not that you have to do that necessarily, but do you see your x-axis? Okay. I want to know where my graph is positive. I want to know where my graph is negative. Let's start, I guess, does it make sense to start with positive? Okay. My graph is positive when it is above the x-axis. Where do you see the graph being positive here? Where is it above the x-axis? Can you visually describe it? Here's the x-axis. Where is this parabola above the x-axis? Is it above the x-axis over here? Yeah. Is that the only place it's above the x-axis? No, it's also above the x-axis over here. Good? Okay, so those are my positive pieces, because so there's more than one in this particular graph. There's 2 places my graph is above the x-axis. Now, when it says for what interval is each function above the x-axis, or positive or negative, when it asks for what interval, we're going to do this in terms of x values. Okay? So, in terms of x values, well, what x value is important here? Where does my graph start becoming positive? At what x values? At -3 and at +3, yes? So at your x-intercepts, because at my x-intercepts, that's when y is 0. So it's neither positive nor negative. So when is this positive over here? When x is -3, or what other x values over here? When x is -3 or what kind of infinite?
Negative.
Negative infinity. Okay. When x is -3 or smaller, can you agree that that graph is positive? Because think about it, it's to the left of -3. So if it's to the left of -3, that's where it's going to be positive. Now, Jocelyn used the idea of infinite, right? So infinite to the left. So there's 2 ways to write this. We could say, and I think, do I have both in my notes? I do. So we could say one option, -infinity to -3. Because my graph is negative, or wrong word, My graph is positive. It's above the x-axis over here. And if it helps, looking for, like think. That's kind of the dividing line, isn't it? Okay, that's kind of the dividing line, is the 3 and the negative 3. Okay. Now, at negative 3, is my graph positive at negative 3?
No.
Is it negative? What number is right there with negative 3? That's the ordered pair negative 3, comma 0. Officially, by definition, 0 is neither negative nor positive. So, with that in mind, I'm going to use a parenthesis. Okay, because negative 3 is not positive. The other way to say this, we were left of negative 3, yes? What kind of numbers are left of negative 3 on number line? Numbers that are negative. They are what in relation to negative 3? Smaller. Or how about less than? So the other way to explain that one is x is less than negative 3. Okay, you can do either or here. We'll have to work to understand both. Now, that was this left piece. Where else is this graph positive? 3 to the, okay, 3 to infinity, 3 to the right. So you could say 3 to infinity. I used a parenthesis on 3 because is the y value at 3 positive? No, the y value at 3 is 0. Okay. Or when is this positive? When x is what? What in relation to 3? When x is greater than 3. Okay. So you can do inequalities or interval notation. Now, I probably should have started with negative. The positive was the harder one to do on this example. The other piece of this is when is this graph negative? Well, do you see? How do we do? I mean, where is that graph negative? It's the U shape that's negative, yes? Okay. Everything that's below the x-axis. So here, that entire U shape is negative, isn't it? It's negative because its y values are negative. It's below the x-axis. How do I describe that in terms of x? When did it start being negative? When it crossed through what x value? Negative 3. So it started being negative here. It's negative, it's negative, it's negative, it's negative, it's negative, it's negative, it's negative. When's it going to stop being negative? When it crosses through what x value? 3. So it's negative between what x values?
Negative 3 and 3.
Negative 3 and 3. Are you kind of with me? It takes a moment to understand this, I know. So we just essentially did interval notation. It starts being negative at negative 3 because it's below the x-axis. It continues being negative all the way till you get to 3. Now, at negative 3 and 3, same thing I talked about earlier. Is it negative at negative 3 and 3? No, because your y values are 0. So these are parentheses again. Okay. How do I write this with inequalities? I think if we talked in this class, no, we didn't really. It's negative when? We just said between negative 3 and 3, yes?
Yeah.
Okay, so the compound inequality for that says you put the smaller number at the left, negative 3. You put the x in the middle. And you put the larger number at the right. And in between here, we're going to use less than signs. Because what that's saying is x is less than 3. Okay? We want to look when x is less than 3 to the left of 3. And we want to look when x is greater than -3 to the right of -3. But when we reverse this, because they're going to want to compound inequality, it's -3 less than x, because you're reversing that x greater than -3. Okay? That's a common way to go between two numbers. Okay, questions I can answer here. We either really got it or we don't have questions to ask, but we're not quite sure yet. So, which is fine. Question?
I still don't understand about the
Parentheses versus brackets?
yeah.
Okay. And so the whole idea of the parenthesis versus bracket here, at this ordered pair, this is the ordered pair 3, 0. And this over here is the ordered pair -3, 0. So at those pairs, that y value is 0. Okay? Y 0, by definition, is neither positive nor negative. So when we use the 3's here we only wanted positive. We didn't want to include 3. So if we would have wanted to include the 3's, we would have used the square brackets. Since we didn't want to include it, we just used the parentheses. Same thing down here. It would be like if we had used less than or equal to, greater than or equal to, that's when we use the square brackets. Okay? But since this was just less than and greater than, we don't use the square brackets. We just use parentheses. Okay, and I know we talked about that a little bit with domain and range yesterday, right? So I said if it touches, if it includes that number, we're using the bracket. Okay, let's try this one. Y equals 2x plus 10. You have a graph. Okay, start off. My graphs aren't always centered the same. Where is my x-axis? You got it spotted? It's way low, isn't it? Okay, and keep in mind, this is a line. It is extending. Okay, we want to talk about positive versus negative. What's key to notice? Where's my positive and negative going to change? At what x value? It's a negative, yeah. Sorry, I kind of wrote on top of it. I don't know. Can you guys, your guys is really small. Can you see it? Okay. Well, I promise it's -5. It's to the left of 0, okay? So this point right here at -5, that is when my graph changes. That's when it crosses through the x-axis, so it changes between positive and negative. Let's work with positive here. Okay. Physically looking at the graph, where's the graph positive? Any place it is above the x-axis, right? So where's this graph above the x-axis? All of that right there is above the x-axis, yes? Okay, so think in relation to this point at -5. Okay, in relation to that point, where is my graph going to be above? It's going to be to the where of -5?
Right.
To the right, yes? What are my options of writing to the right of -5? What are we thinking here? We can think interval notation, or we can think inequalities. Because I'm going to make us talk both. What? We're all hesitant, aren't we? Okay. Where does it start? Where does it turn positive? After you pass through -5. -5 to when? When does it stop being positive? It's going infinitely up and going infinitely to the right. So it is positive from -5 to infinity. Okay, because remember, these are x values that we're doing this intervals in. We're asking questions about the y as it goes up and down, but we're answering with x's. And at -5, it's 0. So it's not positive and it's not negative. So -5 is 0. Or how can I say that with an inequality? When is this graph positive? We said -5 to infinity, and so that's when numbers are what in relation to -5? Bigger. So we can say x greater than -5. Those are both good ways to say positive. Okay. The other part, negative. When is my graph negative? So I'm asking you, when is it below the x-axis? So when is it below the x-axis? -5 and to the left. How do we express to the left of -5? Okay. Can I say x less than -5? I can, because it's numbers to the left of -5. Or -5, where did it start being negative? Infinity, but in the negative sense. So -infinity to -5. Okay. Are we starting to see it a little bit? Okay. I'm hoping we're starting to see a little bit. It takes practice. I get it. Okay. But positive and negative, remember you're looking for above and below the x-axis. That's the definition you've got to remember, is above and below the x-axis. Okay. Okay. What time do we get out of here at? Okay. We've got to talk about this one last section, and we'll start with Savas tomorrow then, okay? So let's try and get the idea of increasing and decreasing. I may have to revisit this a little bit in your class tomorrow. Okay. Positive, negative is one set of definitions. Increasing and decreasing. What's it mean to do increase? Increase is going where? Up. Decreasing is going down. Okay, so a function is increasing. Officially says if the y value is increasing as the x value increases. That's just saying as you move right across the graph, if your y's are going up, as your x's get bigger, it's increasing. Increasing looks that direction, yes? Okay. Decreasing. A function is decreasing if the y value is getting lower, and it says as the x value increases. That's just saying as you move right across the paper. So decreasing is going to be moving in that direction. So on these, we're being asked about increasing and decreasing. Okay? Let's look at this first example real quick so I can get the idea out there. I'm going to do it this way. I'm going to say start at the left side of your graph. If I start here and I start tracing my graph, what direction am I going? Can we agree that we're moving up? So if I'm moving up, what is that? That is increasing. Good. Now, when you give your increasing answer, we're going to use, notice it says for what? Values of x. So, when did my graph start increasing? Way off to the left, yes? What do we express left as? Negative infinity? So we start increasing at negative infinity. Now, when do we stop increasing? when we get where? I believe it's,
4? No.
I wrote over it, but I believe that's a 2.
Oh.
So that's the ordered pair. Okay. It's the ordered pair 0, 2, yes? What is the x value there? No. The x value is 0. So it's increasing up to that y value, but we're giving our answers in x. So it's increasing up to 0. Now, what did it just hit? It hit a really high point, yes? I'm going to throw out the word maximum. Did it just hit a maximum point? Now, what's it do with that maximum point? It starts decreasing. So if it stopped increasing at 0, where's it going to start decreasing? It's going to start decreasing at 0. Does that make sense? Because 0 is the change point now. It's going to keep going down, 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 down. When is it going to stop decreasing? Infinite. Okay. Okay. Got 2 more. Remind me, I may come back to these tomorrow. The back page just has a little bit of, kind of a reference chart. Tomorrow, bring your notes. Must have your iPads with you. Okay? If you know you're not here tomorrow, touch base with me so I can get you set up on Savas before you leave today and you get the homework done over the weekend. Okay?